Good morning to all. Any doubt in last classes? No. Okay. Understand about photoelectric effect. Remember photoelectric effect and about photoelectrons, photoelectric current. Okay. Just recall in your mind. But now we are going to discuss about a new topic. Not a photoelectric effect. Another new topic, because after completed polarizer and analyzer, we are going to discuss one problem, important problem. Okay, but now we are going to discuss about polarizer and analyzer. Already you have studied about some concepts in polarization. Remember? Yeah, just revise in your mind. Okay. To easily understanding about a polarizer and analyzer, first we must draw one simplest diagram. One simplest diagram. Come on, listen. Yeah, this is unpolarized light. Okay. This is one polarized. It is called P1. It is called P1. This is polarized light. Okay. This is polarized P2. Okay. This is I, human I, or U. No problem. Okay. This is polarizer. This is analyzer. Okay. Let us consider first unpolarized beam of light incident on polarizer P1. What is meant by unpolarized light? Yeah, it has vibrations all the directions. That means the vibrations of the unpolarized light will be all the directions like this to the propagation of the light. This is the direction of the propagation of light beam. Okay. Unpolarized light means it has contains vibrations in all possible directions. Okay. But this is called unpolarized light or unpolarized beam of light. It has will be vibrations in all possible directions to the direction of the propagation of the light. Okay, it is allowed to pass on the polarizer P1. Okay, then the light coming out from the polarizer, that is called polarized light. What is the reason? The reason for this, when allowed unpolarized light on the polarizer P1, it is restricted the vibrations to only one direction. Only one directions. So now the light coming out from the polarizer P1, that is called polarized light. That is called polarized light. Okay. Here only one direction vibrations. Okay. Then, so Now P1 is called a polarizer. What is the reason? It is restricted by only one direction. No, that means unpolarized light, it is converted into polarized light by the polarized P1, that is called a polarizer. Okay, then let us consider polarized P2. For particular direction of a polarized P2, for example, any one direction, intensity of the light will be maximum for particular direction. For example, polarized P1 and P2 placed parallel to each other like this. The light coming out from the polarized P2, intensity will be maximum, or intensity of the light coming out from the polarized P2 will be maximum for particular direction. Okay, for example like this. This is P1, this is P2. Both are plane of the polarites parallel to each other. Now, it is kept constant. The polarized P2 rotated through 90 degree like this in crossed position. No, both are in crossed position like this. This is P1, this is P2. Now, when rotating the polarized P2, the intensity of the light starts to decreasing. How? Listen. This is maximum intensity for particular position of polarized P2. When rotated, polarized P2 about the axis of the incident light beam. Okay. Now, when rotating the polarized P2, intensity of the light starts to decreasing. How? Like this. Okay, starts to decreasing like this. And at times, 0, this position, 0. When both are in crossed position like this. This is P1, P2. Gradually, listen here, gradually rotated polarized P2 like this. When coming like this crossed position, that means a 90 degree, the intensity of the light will be 0, completely 0. Okay? So, this light coming out from polarized P1 is called, very good, plane polarized light. Okay, so what will be the function of P2? Yes, here polarized P2 which is used to analyze the light if polarized or not. In Tamil, Pagupaivu, Arayathu. So, the polarized P2 which is used to analyze the light is polarized, sorry, not polarized, the light is polarized or not. The light is polarized or not. So, that is called, yes, very good, analyzer. That is called analyzer. But this is called a polarizer. What is the work of polarizer? Yeah, it is converted into unpolarized light into polarized light. That means the light polarizes by the polarized. That is called a polarizer. That's all. This is analyzer. Analyzer which is used to analyze the light is polarized or not. That is called analyzer. Okay. Then first crossed position, okay, 0. Then again rotated gradually like this. Which one? Polarized P2. So it starts to increasing like this. Starts to increasing. Again 190 degree. So totally, 180 degree. So in 180 degree, intensity will be maximum. That's all. It is going on like this. Okay. So now we can understand about polarizer and analyzer. Yeah, very simple this. Okay. At the same time, let us consider I is the intensity of the unpolarized light. I is the intensity of the unpolarized light. Okay. The intensity of the light coming out from the polarizer P1 will be I by 2. Okay, sir. What happened when unpolarized passing through the polarized P1? What happened? Yeah, one half of the intensity it is restricted by polarizer P1. Okay, so the intensity of the polarized light coming out from the P1 will be compulsory half of the intensity when we comparing unpolarized light. Clear? You can clear about a polarizer and analyzer. Polarizer. Unpolarized light converted into polarized light by polarizer. But analyzer, it is used to analyze if the light is polarized or not. That is called analyzer. That's all. Okay, then we are going to discuss about polarized light and partially polarized light. Okay, polarized light or plain polarized light, partially polarized light. Okay, listen, very simple this. Listen. Plain polarized light and partially polarized light. Okay, polarized light or plain polarized light and partially polarized light. Okay, listen. Very simple this. First one. See the diagram. First you try to diagram without any mistake. Draw the diagram without any mistake. You can write the statements or explanation of the diagram only without any mistake. Clear? Okay, listen. One of the simplest concepts is, don't worry. Yeah, this point, this position, maximum intensity. So here y-axis denotes intensity. This axis denotes rotation of the P2. That means a polarized 2 or analyzer. No, yeah. So this is 0 degree. This is 90 degree. This is 180 degree. Like this. This is in this axis taking intensity of the light. Okay. Listen here. First one. This diagram for polarized light. What? Polarized light. Okay, listen here. This is polarized P1. This is a polarized P2. Okay. For particular position, intensity of the light will be maximum. Okay, right. First, let us consider both are parallel to each other. Okay. Now, listen properly here. If the intensity of the light varies maximum to 0 for every rotation of 90 degree of the analyzer. Clear? If the intensity of the light varies maximum to 0. Listen here. What is maximum to 0? This is maximum intensity. This position. This is 0 intensity, not minimum. 0. No light coming out from the analyzer. Clear? So intensity will be 0, not a minimum. 0. So if the intensity of the light varies from maximum to 0 for every rotation of 90 degree of the analyzer. Okay. Now this is called plain polarized light. Okay. That's all. Again rotating. Gradually like this, the polarized P2, yeah, starts to increasing at 180 degree. I am correct or not? Yeah, this is shown in the figure. Very simple this. Alternately going on like this. For every 90 degree of the rotation of the analyzer. So that is called a polarized light. From maximum to 0. Okay, then come here. Partially, in Tamil, pagudi. Partial means pagudi. In Tamil, pagudi. Partially polarized light. Partially polarized light. Yeah, same diagram, but a simple correction from the first diagram. Yeah, listen here. Okay. This point, this position, yeah, maximum intensity. Maximum intensity. This is 0 degree. Here, yeah, 90 degree. Here 180 degree, here 270 degree, going like this. Then, if, yeah, you can say very simply, that's all. If the intensity of the light varies from maximum to not 0 but minimum, that's all. If the intensity of the light varies from maximum to minimum, this position, it is called minimum position. How? Listen, come on here. Maximum intensity. This is P1. On rotating P2, gradually it starts to decrease. No? Yeah. Yes. Minimum intensity here. Listen. Like this, not 0. So, if the intensity of the light varies from maximum to minimum, not 0. Now the light is called partially polarized light. When, how, yeah, remember, keep in your mind, that means the first diagram. Okay, the light coming out from the polarized P1, that is called polarized light. When on rotating P2, the intensity of light varies from maximum to 0. Now the incident light on the P2, that is called a plane polarized light. On the other hand, the intensity of the light varies from maximum to minimum. Yeah, now that is called partially polarized light. Clear? Okay, next we are going to discuss about one important 100% repeated question in photoelectric effect from your NEET examination. Okay? Okay, listen. Light of two different frequencies. So energy will be same. Okay? No, you are wrong. The energy also will be different. Because E is equal to H, you know. Yeah, this is energy of instant photon on metallic surface. So different energy, not same. You are wrong. You are correct. Okay. Whose photons have energies 1 electron volt and 2.5 electron volt. So E1 and E2 respectively. Illuminate, that means incident. A metallic surface. So here metal surface, yeah, fixed. That means only one metal surface. Very good. Work function will be same. When changes metal surface, work function of the metal surface changes. Okay, a constant. So same. Which one same? Yeah. Pi naught. It is already told you a lot of times. It is given in your textbooks taking for work function. But simply keep in your mind, not pi naught or pi. Here remember W. Very good. Whose work function? W 0.5 electron volt. Given in electron volt, energy also given in electron volt, so no problem. No conversion into joules. Okay, so listen. Ratio of maximum speed or velocity, speed V. Okay, maximum speeds V. Emitted electrons will be, okay, listen here. See the four options. Okay, listen. This is metal surface or metallic surface. Instant two different photons. Listen. Okay. Its energy of instant photon on the metal surface. Yeah, caps E. Here two different photons. So E1 is equal to 1 electron volt. Okay. Same metal surface. Same metal surface. Okay. Second photon of energy 2.5 electron volt instant on the metal surface successively அடுத்தடுத்து 2.5 electron volt. Illuminate means instant. Metallic surface. Whose work function? Yeah. Work function of this metal surface W is equal to 0.5 electron volt. For this surface, yeah, W is equal to 0.5 electron volt. Ratio of maximum speed. Emitted electron, okay, when instant light or any other radiations on the metal surface, yeah, electrons are emitted from the metal surface, that is called photoelectrons. Okay, not photons, photoelectrons. Okay, emitted electrons will be, that's all. Okay, what is already told you? What is the main and basic 100% important formula? Yes, very good. E is equal to, very good, W plus KE. Single formula, keep it in mind. After keeping this formula in your mind, yeah, you can cover 85% of problems in dual nature of radiation and matter waves or elemental to photoelectric effect. Okay, E is equal to W plus KE. Energy of instant photon, work function of the metal surface, cutting edge of the emitted photoelectrons. Okay, in other hand, E is equal to W plus, yeah, half mv square maximum. That's all. Simple. It is equal to h nu. It is equal to h nu naught. It is equal to, or it is equal to half mv square maximum. Or, yes, very good, EV naught. V naught means a stopping potential. No need here EV naught. Yeah, up to this enough. Okay, now rearranging this equation. E minus W is equal to half mv square maximum. Okay, here, because here we want to calculate ratio of this simple one thing. Okay, so that, listen, half mv square maximum is equal to E minus W. Okay, here two photons now. So here considered two different electrons now. So half m V1 square maximum is equal to E minus W. Half m V2 square maximum, it is equal to E minus W. But work function same, no? Yes. So E1, E2, that's all. So substitute the values in these two equations. Now it gets ratio of velocity of or speed of two electrons emitted from the metal surface. That's all. Mass same, no? So leave it. E1 value. Where is E1? Yes, 1 electron volt. Work function value? Yes, 0.5 electron volt. Electron volt, no problem. 2 2 maximum is equal to E2. Very good, 2.5. Work function, same now. Yeah, 0.5. Here. 1, this is 2. Okay, clear? Yeah. What to do now? Yes, 1 by 2, that's all. 1 by 2 means half m cancel now. Yeah, that's the remaining. E1 square maximum is equal to 1 minus 0.5. E2 maximum square is equal to 2.5 minus 0.5. Okay, that's a very simple. Okay, 1 minus half, so 0.5. 2.5 minus 0.5, yeah, 2. So how many times? Half, 4, sorry, 2. 4 அரை 2. 4 அரை 2. That means that's all. 1 by 4. So V1 maximum whole square by V2 maximum whole square is equal to 1 by 4. But here asking at a square of a speed of a photoelectrons emitted from the metal surface. Okay, speed. Only asking here speed. So that V1 by V2 is equal to 1 by 4. Yeah, 1 by 2. Therefore, V1 is to V2 is V1 is to V2 is equal to 1 is to 2. Okay? Clear? 1 is to not 12, 1 is to 2. 1 is to 2. Clear? So which option? Come on here. Yeah, very good. Second option, clear? Very simplest but a repeated question in your NEET examination. Simply keep in your mind only one formula, E is equal to W plus Ke. So that means energy of incident photon is spent into two ways. In first way, yeah, what is mean by work function? Energy required to liberate an electron from the metal surface. So it is spent to liberate the electrons. Then half of energy of the incident photon spends as kinetic energy of the emitted electrons. That's all. This is very, very important formula. Thank you.